All right, so if you've ever worked in, high-end AV installation, you know the absolute tyranny of distance.
Oh, yeah.
Standard HDMI cables, they just choke after about 15 feet when you're trying to push massive 4K signals.
I just die.
Exactly. And that central problem is precisely why we're doing a deep dive today into the spec sheet for the PureLink HTE-T III RX 4K HDR extension receiver.
And our mission really is to decode how this device actually conquers that distance problem.
Okay.
At the heart of it all is HDBaseT. And if you're curious, that's just the standard that lets us transmit high-def video, audio, even power, all over one simple, low-cost CAT cable.
So the same cable you'd use for your internet connection.
The very same. We need to understand the critical numbers that make this extension actually work for, the modern 18 gigabit world.
Okay, let's unpack that number. 18 GBPs. That is a huge pipe of data. We're talking, enough bandwidth to download 3 movies every second?
It's massive.
And the specs say this receiver uses a standard Cat5 or Cat6 cable to stretch that signal. So what's the most important metric on this whole spec sheet? Where's the compromise?
It's what I call the distance divide. You can see the performance drop off so clearly.
How so?
Well, if you're pushing standard Full HD 1080p, this device can hit 100 meters.
Which is 330 feet. That's impressive.
It is. But the moment you jump to the really high demand 4K HDR content, that distance immediately shrinks to 70 meters.
So you lose 30 meters. Why? Is it purely a signal degradation issue?
It perfectly illustrates the bandwidth squeeze. I mean, to be compatible with modern standards like HDMI 2.0a, you have to support 4K at 60 frames per second.
And that's the 4.4.4 8-bit color, right?
Exactly. But to squeeze high dynamic range, the 10-bit color, down that same wire,
You've got to compromise somewhere.
you do. It shifts to 4.2.0 color sampling. That's the strategic compression you need to push 18 gigs of data down a copper pair over 70 meters.
And crucially, the audio has to keep pace. The source material emphasizes pure, uncompressed 7.1 channel digital audio.
Absolutely. You're getting DTS HD master audio, Dolby True HD, all the high bitrate formats, the full signal fidelity.
So once we've solved the data problem, we have to solve the practical problems, like power.
Right. And control. This is where PoC power over cable comes in.
Which is a huge benefit for any installer.
A lifesaver. It means the receiver unit doesn't need its own plug. It just draws power right from the transmitter side. It makes the installation so much cleaner.
And beyond just simplifying power, professional setups demand robust control.
For sure.
I'm seeing CEC support, but also full duplex, RS-232, and bidirectional IR.
And you need those. If you're hooking this into a sophisticated automation system, you absolutely need those reliable legacy control options.
Okay, and this next section of the spec sheet, this is what justifies the enterprise price tag, I think.
This is the robustness factor. We're talking about an MTBF, or mean time between failures, of 50,000 hours.
Wow. That's over 5 years of constant 247 runtime.
And you also see serious ESD protection. I mean, it's designed to handle massive static shocks or power surges, and the video latency is under 20 milliseconds.
Which is essentially instantaneous. You'd never notice it.
Never. This gear is built to live in a high-demand commercial rack and just work.
Before we wrap up, we should briefly touch on this bit of jargon that comes up a few times. TAA-compliant. What is that?
It's mostly an administrative thing. It means the product complies with the Trade Agreements Act.
Making it eligible for certain U.S. government contracts.
Exactly. So for you listening, what does this all mean?
Yeah, what's the big takeaway?
This receiver is an elegant bridge. It connects the massive demands of 4K HDR with the physical limits of wiring. It uses this auto-equalization tech to constantly correct signal loss across the copper cable, maintaining that 18 GBPs connection when a normal cable would have just failed instantly.
That's the key synthesis. But for the true learner, here is one final thought to consider. When a product guarantees stable 18 gigabits per second transmission, is that performance more reliant on the purity of the physical components? Like the 6-layer printed circuit board design and the controlled impedance of the copper? Or is it more about the cleverness of the signal processing software running inside that HDBaseT chipset? Which matters more, the physics or the programming?